Okay, so I'd like to tell you something about surge protection because I bought an electric car, and after a few months the onboard charger was taken out by the surges, you know, these high voltage transients which sometimes appear on the grid. Uh, Maybe not in every country, but in my country, Hungary, so the system is pretty unsafe. There is not much protection against these high inductive voltage spikes, and the standard official protection is based on a varistor, and it starts protecting the circuit above the voltage level of 270 volts. So the nominal level is 230, but due to this solar panel fad which is on nowadays, the voltage levels are pushed up to 240. And but there is a chip on the charger, in the charger, which is very sensitive, and so even 250 volt is enough to kill it. And the change of a reconditioned onboard charger cost me like $500, and so I paid all the money that I had saved on fuel to the garage. So, and so it wasn't real good news, and uh, I got pretty gloomy about it. But I had done some experiments with the Bedini circuit and the dual sieve circuit, and maybe if you know this technology, that the protection of the transistors or the MOSFET is usually implemented by installing a neon bulb on the between the emitter and the collector or the base. Usually the emitter and the collector, okay, and so when the charger is not connected to the battery, the neon bulbs light up, or a neon bulb lights up, and it dissipates the extra energy, which otherwise would kill the transistor. Yeah, if you see my transistors, they are all dead. Okay, and this is just part of it. Okay, so the transistors and the MOSFETs are pretty sensitive, and so I thought if it works with the Badini, why it shouldn't work with the why shouldn't it work with the charger? All right. So, but since we are not working with 30-40 volts, but 230, I decided to build a neon bulb surge protector, and I installed it in this bug, not bug zapper. I think it's a bug in, yeah, repellent or something. It's an electronic device because it gives out a high frequency voice, and it keeps the bugs away. But it didn't work so well, and so I installed this terminal block inside. Probably you can see, and 4 neon bulbs. Okay, the neon bulbs light up usually at 80 or 90 volts, and but there are 4 of them, so if you multiply for example 80 volts by 4, so the result is 320, which is way more than the 230 volts. But okay, so it's important, because it's not the effective voltage that matters, but the peak voltage, which is about 400 volts. Okay, so because the sinus wave, they have to calculate with the peak value, okay, not the effective value, and this is why the mathematics don't add up. But yeah, I didn't know that, and I stopped the development at the beginning, and then the car broke down. So it cost me a lot of money, but you pay for your mistakes. I think I've learned my lesson. Anyways, so I'd like to demonstrate how it works. Just a sec. Good. Okay, so I put on the gloves not to get electrocuted. Yeah, because it's dangerous. So if you decide to build something like that, okay, so do it at your own risk. All right, this is the disclaimer. Or ask, for professional help. All right. Now let's check the voltage. Sorry, the other way. Okay. So here is the extension and cord. 243. Okay, so it's way more than 230 already. Now if you connect this protector into this, okay, so they're dark. Okay, so I think it's pretty visible. Maybe I should zoom a little on it. Maybe I can try to zoom on it. Yeah, not very good this. Oh, whatever. Okay, so maybe this is maximum. Oh no, here it is. Okay, it's a little better. Okay, so okay, so they're dark. Okay, now behind the multimeter you see this ugly looking contraption, which is an isolator transformer that I built from a microwave oven transformer, but it's also dangerous, so be careful. And but I got the secondary wrong because it is hand wound. Okay, so and I put more turn on the secondary than there was on the primary, so it gives out a little more than the line, sorry, the voltage level of the. Okay, so it's 255, right? Okay, 255. Good. Now let's check the protection. Now I'm connecting it to the protection here. Hope it stays. Okay, good. Here's the other prong. Now. Okay. Yeah, okay. So you see that these bulbs are lit. Okay, so the vibration of the bulb is probably due to the camera frame speed or something like that. So they are pretty steady, not so steady, but pretty steady to the naked eye. Okay, so much steadier than here. But you see that the extra energy is dissipated in the form of light, and this is why it can save your electronic devices, internet, you know, switches and routers and other devices, satellite receivers, set-top boxes. So these devices are pretty sensitive as far as I know, but with a cheap solution like that, you know, 4 bulbs, 4 neon bulbs, you can save them. But I was lucky because this isolation transformer came very handy in the development project. Okay, now I want to show you the Bedini. Yeah, here is a okay. So here is a battery. Okay, no, I don't need the gloves anymore. Try to zero the multimeter. As multimeter is getting very unreliable. Now let's check the voltage level here. It's getting very ornery. Come on, do something. Okay, so it's 1300 millivolts. Okay, so not very fully charged. And here is this Bedini solid state charger which I built. Let's see how it works. No big deal. Okay, 1. The negative goes here. Sorry about the crappy implementation, but so I'm sure that you see the point. It's not for entertainment. Yeah, okay, so it buzzes a little, or you see at 1800, almost 1800 millivolts. Okay, this is the charging voltage. Okay, but I don't use it for tangling for battery charging. But see inside, probably you can see the neon bulb. There are 2 of them somewhere, maybe. Okay, good. Couldn't get the top off. Okay, probably you can see. Yeah, they are connected between the collector and emitter, and the collector and base, or probably not the emitter and the base. Okay, but if I short them out or put a battery, okay, so out, they go out. Maybe you can hear the difference. Short it. Okay, so you can play with it. It's very robust. Okay, so nothing kills it. Okay, very good. But without the neon bulbs, you know, the result is dead the transistors. All right. So I think this is what I wanted to tell you. What else? Yeah. So the okay, let me unplug it because it's a little bit disturbing here. Okay. Yeah. Okay. So again, it's dangerous. So be careful. And yeah, I think I've touched upon everything I wanted to tell you. Okay. So the neon bulbs work. They are very simple vacuum tubes actually, because they. So the neon atoms just float around happily if there is an electrical field. But if the electrical field is increasing, so they get more and more excited. I mean the electrons, and above a certain level, which is called the arc over voltage, they just get torn off from the atoms and start floating freely between the electrodes, and they behave like a piece of wire. Okay, so they actually just short the circuit. But whenever the voltage level drops, so they become insulators. Okay, so very interesting and very, very fast devices, and much more reliable, I think, than the varistor based system, because a varistor just consumes itself. Okay, and after a set amount or a certain amount of surges, you have to change the varistor, I mean this whole fixture in the circuit. But the neon bulbs can do it indefinitely. Okay, so that you don't have to worry about them if you connect this device parallel with the charger or with the adapter. Okay, so maybe there's a power strip, okay, or a distributor head, and you just plug in before the charger or before the adapter, and it screens out or filters out these surges. Okay, so actually this is what I wanted to tell you. Be very careful, and if you find it useful, please send it to others. Thanks for watching and listening. Thanks for bearing with me.